Question 28. Now, when it says by considering bounds work out the value of v to a suitable degree of accuracy, you've got to work out the lower bound and the upper bound and take it from there. So, lower bound, how do we make v as small as possible? Well, in that case, we need to have a as small but b as big as possible. When you have a division, to make it as small as possible, it's small divided by big. So the smallest value that a could be, that rounds to 6.43, correct to 2 decimal places, is 6.425. If you round that, that rounds to 6.43. So that's as small as it can be. Now this has to be as big as possible, okay, and yet still round down to 5.514. Now that is giving us 5.5145. Now just be careful, I know in theory that does round up, so that would round to 5.515, but so the true answer should be 5.5144999999. But for bounds questions, they expect you to just basically just go that extra little bit because the difference is so small it doesn't make a difference. So note how we've actually rounded this to 5.5145 for the highest bound of this. So using your calculator, you do that divided by that and square root it and write down exactly what your calculator says. You then repeat to get the upper bound, the biggest value for v. To get v as big as possible, you need a as big as possible, b as small as possible. That's these values. Using your calculator, you get this. So that would give you probably 3 or 4 marks. Now, we've got to go a suitable degree of accuracy, so we go to as many decimal points as we can where they round to the same number. So to 1 decimal place, this would be 1.1, this would be 1.1, so that's fine. 2 decimal places, this would be 1.08, this would be 1.08, still fine. 3 decimal places, this would be 1.079, this one will be different, 1.080. So they do not agree to 3 decimal places. So you can't round that far. So the furthest you can round is to 2 decimal places, which was 1.08.